Good morning, student. I am Professor Nguyen. As I already told you that I'm going to make the video cover section 1.6 of the textbook, and we've been doing solving equation. In the last lecture, we stopped at solving radical equation and rational equation. However, in this video, I'm gonna do some more example of radical equation and rational equation. Then we will jump to how to solve a polynomial equation and absolute equation. So first, we want to take a look at again radical equation. Okay, and the goal of solving radical equation, we always want to have radical on the left hand side and everything on the right hand side. We try to bring the radical equation into the form square root of a equal b, so that we can square both sides and it gives you a equal to b squared. This is our goal. Okay, and most of the time if you see the radical equation with one radical side, then you can do like this right away. However, if we see the radical with two radical sides, then you can leave one radical side on the left side and the second radical side on the other side, and then we square both sides. Okay, but in the first example, I want to do the radical equation with one radical side only. For example, I want to do let's see, let's pick just something simple. For example, like 6 equal 9 plus square root of 5 minus 3x. Okay, so you see that the radical on one side already, and the other side we have number 6. I'm sorry. However, if we looking at carefully, you see that on the right hand side we also have number 9. So it's good that if you just go ahead and subtract both sides by 9. The question is, can we just go ahead and erase both sides by the second power right now? Yes, you can. However, it's much better if you just go ahead and get rid of number 9 first. So if you get rid of number 9, you have negative 3 equal to radical of 5 minus 3x. Okay, then afterward you squared it. Okay, however, I can jump into conclusion right away that we don't have solution. How I know that? Okay, just go ahead and square it and you will see. So if I just go ahead and square it, it give you both sides. If you square both sides, you can get rid of the radical, and on the left hand side you have 9, and I solve the basic linear equation. You have 9 minus 5 is 4, so x equal to negative 4 over 3. Okay, so I'm gonna just go ahead check the answer. So I try to check. So check square root of 5 minus 3 negative 4 over 3, which is give you what? It give you cancel that, give you square root of 9, and square root of 9 give you 3, and you see that we don't have the solution right here, right? Because square root of 9 equals 3, and you see that it's not the same as the left hand side negative 3. So I can jump into conclusion that this equation has no solution. Okay, has no solution. Okay, let me do another example that has two radical. Let me see. Possible number 70 right here. square root of 8 minus p equal, minus square root of p plus 5 equal 1. Okay. Okay, so you see that again, I already told you the goal is always want to bring radical on one side. So is it okay to square right now? Yes, you can, but it's even better if you put one radical on each side then square it. So I'm gonna just put one radical on each side. This is minus, I add both sides. Okay, so I have this, then I squared it. When I square this, I give you a minus p. Then I square this, it give you 1 plus 2 square root of p plus 5 plus p plus 5. Okay, now I try to combine like term on the right hand side, so I'll give you 6 plus p plus 2 square root of p plus 5, because p I keep it, 5 plus 1 is 6. Okay, then I combine like term, so I move this to this, give you 2, so give you negative 2p equal 2 square root of p plus 5, and I divide both sides by 2, give you negative 1 minus p equal p plus 5. Then I start square both sides, give you 1 minus 2p plus b squared equal p plus 5, and it look like that we're gonna have a quadratic equation, right? Because this is a second degree right here. Okay. So what we have p squared minus 3p 1 minus negative 4 equals 0, and I try to solve it by factoring. So we're gonna have negative 4 plus 1 equals 0. Then p equal negative 1 and p equal to 4. And again, you should check if it work or not. Okay, so negative 1 here give you negative 9, will be 3. 2, 3 minus 2 is 1. So this is work. 4, you plug it in, 8 minus 4, 4 square root 4, 2, 9, 2 minus 1, 2 minus 3 doesn't work. So look like that this one is not good, right? It's not good, because look at that, 4, right? 8 minus 4 is 2. 8 minus 4 is 4, square root of 4 is 2, and 4 plus 5 is 9, square root of 9 is 3. So 4 minus 2 minus 3, 2 minus 3 is negative 1. So this just doesn't work. This just doesn't work. So look like your answer is just this. So you can see that p equal 4 doesn't work because I plug it in, it doesn't give you 1 at all. Okay, so this is just one of the methods when you're dealing with radical equation, when you having two radical sides, which is I'm gonna bring one radical side on each side of the equation and start squaring both sides of the equation. However, this equation could be solved in another way, with another way. Okay, let me go through the second way for you. So let me rewrite it. So 8 minus p, okay, minus p plus 5 equal 1. So instead of having each radical on each side of the equation, I can start squaring from here. I can start square both sides from here. So if I just go ahead square both sides, p plus 5 square equal 1 square equal 1. Okay, so this one, the part right here, I have to expand them. So this one become what? Become 8 minus p minus p plus 5 time it square root of 8 minus p minus square root of p plus 5. equal 1. Then I'm gonna start distribute it. Okay, I'm gonna start distribute. I'm forwarded it. Okay, so give you what? It give you a minus p minus square root of a minus p times square root of p plus 5 minus a minus p times square root of p plus 5 plus p plus 5 equal 1. Okay, then this one give you what? A minus p minus 2 times a minus p plus 5, okay, plus p plus 5 equal 1. So the part right here and the part right here, I combine it. It's become -1 here, -1 and -1 become -2. And two radical, I can combine this under one radical. Okay, under one radical. Now I'm going to start combining the like term again. So negative p gone, so give you what? -2 square root of 8 minus p plus 5, give you a plus 5 is 13 equal 1. So we're gonna have square root of 8 minus p plus 5, okay, -2 equal to 1 minus 13 is -12. And again, I divide both sides by -2, so you have 8 minus p plus 5 equal to 6. Okay, so you see that so far this method, this approach is kind of a little bit more complicated. I mean, it's just more step for you to do, and you must be able to recognize the similar term right here. If you cannot, then it's very hard for you to do. But anyway, sooner or later you get the same answer. So I'm going to start squaring both sides. Okay, so if I square it, I throw away the radical, and I square it, give you 36. And I have to distribute one more time. So I give you what? After I distribute, I will see the radical equation. So I'll give you 8p plus 40 minus p squared minus 5p equal 36. So negative p squared plus 3p plus 40 equal 36. So negative p squared plus 30p plus 4 equals 0. I'm gonna bring to the right hand side, or I multiply both sides by -1 because I hate the negative sign primitive. So I'll give you p squared negative 3p plus 4 equals 0, and you see that it kind of the same thing here. I mess up with sign or not? Let's just want to check. Just want to check what we have last time. Oh, that's -4, but I have is +4. So I think I'm kind of mess up something. I think I kind of mess up something. Go ahead and recheck it for me, okay? 2 p plus 5. Okay. 13. 1 minus 13 negative 12. So give you 6. A minus p plus 5 equal to 36. 8p 40 negative p is negative 5p. Oh yeah, so right here it's negative. So you see that it's give you the same answer, the same quadratic equation as last time. So you have p here and -4 here plus 1 here equals 0, and p equal -1, p equal 4, and we're not gonna get 4. We're gonna take -1 after you plug it back into the original equation to recheck. So you see that in this approach, it takes like almost the whole page to get it. Okay, but the other approach takes kind of half a page or only. So if you have the equation, the radical equation that contains two radical, okay, if it contains two radicals, it's good. It's much better if you have one radical on one side and the other radical on the other side, and you start squaring. Because if you bring two radical on one side and you start squaring it, and you see that it takes a lot of time right here. Okay, so that's all about for radical equation. The next part I want to talk about is the rational equation. Okay, and I also mentioned that rational equation is basically the word rational comes from the word ratio. So rational equation basically is just an equation that contains the term which is in a fractional form. For example, let me see. For example, this one, 3x over x minus 5 equal to x plus 1 plus 2x squared plus 40 over x minus x squared minus 4x minus 5. So when you solve rational equation, and because it's rational because of fraction, most of the time we have to combine like term. Most of the time we have to find least common denominator. I'm sorry. So but in order to find least common denominator, you must have the same denominator in order to combine two fractions together, right? Okay, and the first step you have to do when you solve rational equation is you have to find GCF and factoring. You have to find GCF and factoring as much as you can. Okay, so we're gonna find GCF of the first term of each term, or try to factoring each term so that it's in the factoring form. Okay, so that we can find least common denominator. So if you look at the first term right here, there's no way you can find GCF or factoring. This one, no way either. However, this one you can, right? If you look at it on the top, let me just rewrite it. If you look at the top, you can find GCF. Right? Common factor is 2, so I take 2 out, so give you this. And the bottom is trinomial, so we can factor trinomial here. So become what? X negative 5 plus 1. Okay, and after you factor this trinomial, you see that at the bottom of each term we have x minus 5, x plus 1, x minus 5, x plus 1. So they're kind of the same thing in some way somehow. So what I'm going to do, I'm going to just go ahead and combine line term, combine two terms here. By finding the least common denominator, I'm going to just go ahead and leave x minus 5. Okay, so in order to have the same denominator, I'm going to multiply the top and bottom here by x minus 5. Okay. Now what? We have two fractions with the same denominator, and we have two fractions with the same denominator. When we add it, we just keep the denominator when combine the numerator, right? So I'm going to just again I go ahead and keep whatever it is on the left hand side. Okay, and the right hand side have what? X plus 1 and x minus 5, and I combine whatever on the top. Okay. 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 So I'm gonna show whatever on the top I distributed. I try to combine that term to make it more simpler. Okay. Alright. again, I can combine the top, right? So 2x squared plus 2x plus 30 equal x plus 1, x minus 5. Okay. Now what? On the left hand side I have x minus 5, on the right hand side I have x plus 1, x minus 5. So I have two equations, two fractions equal each other. And in order for two fractions to be equal each other, okay, when you back in the day when you learn how to compare fraction, you try to get the same denominator and you compare the top. So if two fractions equal to each other, it means that we have to convert those two fractions to with the same denominator. Okay, and we're gonna set up the numerator equal each other. Okay, or over here you can cross multiply, or another way you can go ahead multiply both sides by x minus 5. Okay, so there's so many ways to get it. However, I think the best way here, I'm gonna just go ahead multiply the left hand side by x plus 1. Okay, I multiply the left hand side by x plus 1 so that I have two fractions with the same denominator. And just think about it, if you have two fractions that has the same denominator and those two fractions are equal each other, so the top, which is the numerator, must be equal each other. So this is equivalent to the top equal each other. Okay. Alright, so I set up the top equal each other because the denominator equal each other already, and two fractions equal each other, so the top must be equal each other. Okay, 2x squared plus 2x plus 30. Now I'm going to combine like term, give you x squared plus x minus 30 equals 0. Alright, and now I can factor this easily. Let's give you plus 6 negative 5 equals 0. So x equal 5, x equal negative 6. And again, I have to check. Let's see it work or not. If x equal 5, 5 minus 5 is 0. There's no way we can divide by 0. So x equal 5 doesn't work. Okay, I know right away. Well, you can plug into the original one. However, if I plug in negative 6 in, okay, if I plug negative 6, the answer works. So this rational equation has only one solution. Okay. So I mean, that's the first example of rational equation. Let me see. I can give you another example of rational equation or not. I can do like, I can make up something for you. You mean something I think simpler. You know, example 2. For example, I have x plus 1 over 5 over 3 minus 2x minus 4 over 6 equal negative x over 2. This is also a rational equation. However, the denominator don't contain the x variable. It means that we don't have to factor. So this is simpler than the example number 1. Okay, so in order to combine these two fractions on the left hand side, just find least common denominator and multiply the top and the bottom by 2. And remember, when you multiply a sum by a number, you gotta put parentheses, okay? Because if you don't put parentheses, it's totally different. Okay, so you have what? So give you 2x plus 1 equals 6 minus 2x minus 4 over 6 The minus here is right on the same level with the bar. It means that this is a minus of the whole thing. Okay, it's totally different if you put a minus here. Okay, if you put a minus here, then it's just the minus 2x. Okay, but this is minus of the whole thing. Okay, so I have the same denominator already. I'm going to just go ahead and combine like term. See, and because it's a minus of the whole thing, I have to put parentheses. A lot of students don't put parentheses, which is give you wrong answer. So I multiply them. Okay, so 2x gone, give you 2 for 6. 6 divided by 6 is 1. So look like that your answer is x equal -2. X equal -2. And I'm gonna check it. X -2. I'll check it. It's -2. -2 plus 1 is -1. -2 times 2 is -4. -4. Alright. Original is this -2 plus 1 -1 minus -2 times 2 is -4. -4 is -8. So -8 over 6 equal 2 over 2. Because -2 here, -2 and negative become positive. So we have -1 plus 8 over 6, right? Equal 1. Let me see. -1/3, or over here -1/3. The original question is this. Okay. So if I let's go in the denominator, give you 6. 6 divided by 3 -2 plus 8 is 6 over 6, give you 1, equal 1. So it works. Alright. So every time you solve a rational equation or you solve radical equation, you always have to check. Okay, because if you don't check, then the answer could be extraneous solution. Okay, if you don't check, sometimes it give you the sometimes the conclusion is just no solution. All right. Okay, so on the third part of the lecture, I want to talk about how to solve absolute equation. Okay, absolute equation. Okay, and the method of approaching this kind of equation is kind of the same as solving a radical equation. It means that you try to bring the whole equation to the form absolute of a equal b. Okay, then instead of a equal to b squared as a radical equation, we're gonna have absolute a equal b, a equal b, or a equal -b. Don't miss the word or, okay, because the formula to contain or. So if you had an equation that contain only one absolute sign, for example, like 5 absolute of 2 minus 4t equal 50, then all you have to do is you're gonna get rid of everything and keep the absolute sign on one side of the equation, and then apply the formula, this formula. Okay, look at the example over here. We have number 5 in front of it, and in order to apply the formula, we're not allowed to have any number in front of it. So I just go ahead, divide both sides by 5. Okay, divide both sides by 5. Then I can apply, because I can apply the formula absolute a equal b. So a in this case this, and b is this. So this gives you 2 minus 4t equal 10, or 2 minus 4t equal to -10, and I can solve it as usual. T equal -2 and -12, so t equal to 3. And again, don't forget checking all the time. So I'm going to check -2 here, -2, -8, -48, 8 is plus 2 is 10, 5 times 10, 50. So this is what? 3, and -12, -12, 2 minus 12 is -10, so absolute -10, 10 times 5 also give you 50. So, well, okay. However, if you have the absolute equation that contain two pair of absolute bar, okay, what I mean over here is something like this. Absolute of 3x minus 4 equal to 2x plus 1. Okay. So we're going to use another kind of formula. So we're going to have absolute of A. The formula is absolute of A equal absolute of B. Then A equal B. Or A equal negative B. So A in this case is 3x minus 4 and B is 2x plus 1. So if I just go ahead apply the formula, okay, if I just go ahead apply the formula, I have I have 3x minus 4 equal to 2x plus 1, or 3x minus 4 equal to negative 2x plus 1. Okay. And again, we're going to solve for that. So your answer should be x equal 5. I'm going to distribute this. So 5x equal to -1 plus 4 is 3. So x equal 3 over 5. And again, I always have to check. So 5 here, 5 times 4, 5 times 3, 15. 15 minus 4 is 9. Square root of 9 is 9. Alright. 5 times 3, 15. 15 minus 4 is 9. Yeah. So 5 times 2 is 10. Okay, 5 times 2 is 10. Okay, hold on. Did I miss something? Okay, 5 times 2 is 10. 10 plus 1, 11. So this is on, doesn't look like it work over here. Okay, it doesn't look like it work. Let's check the 3 over 5. Let's check 3 over 5. Oh, let me see. This is work. It should work. 5 times 3, 15. 15 minus 4, 11. I'm sorry. 15 minus 4, 11. So it is work. Okay, and 3 over 5. 3 over 5 will be 9 over 5. 9 over 5 minus 4. Okay, and over here I have 6 over 5 plus 1. Okay, 9 over 5 minus 4 is 6 over 5 plus 1. It's also work. Okay. Alright, so in this equation we have two answers. So most of the time I give you just two pair for solving the absolute equation and solving the radical equation. I just give you two pair of radical or two pair of absolute. Okay, so I'm not going to give you like three pair of absolute equation. That is too much for you. And yes, however, we do have something like that. We have like 3 pair or 4 pair absolute equation, or some radical equation can contain like 3 radical sign, 4 radical sign, or with a higher radical, for example, fourth root radical or 6th root radical. However, on the test, I'm not going to give you like that. Okay, the assignment, maybe you see it. Probably I didn't put any question like that either. However, on the test or the exam, I'm not going to put like that. I'm going to just put something simple as this, so that you remember the formula, because you in college algebra, you don't need the high one. Okay. All right. So that's all for absolute equation. Another kind of equation I want, this is the last one. This is polynomial equation. polynomial equation. Okay, actually you were introduced polynomial equation already when you solve quadratic equation, because quadratic equation is kind of second degree polynomial equation. So right now we want to take a look at deeply, in a deeper way. Okay, we want to solve polynomial with one or two higher, 1 or 2 degree higher. For example, like we want to solve a cube root, the cubic equation. I mean the third degree polynomial, not cube root. I'm sorry. Or I want to solve the fourth degree polynomial. How we do that? Okay, and we have a couple ways to solve a polynomial equation. We can use formula. A lot of, for example, like the third degree. Some mathematicians already found out the formula to solve for that. Okay. However, that method I don't want to mention in this lecture or in this course, because you have to memorize kind of very complicated formula. So I want you, the second method I want you to learn is factoring. So most of the time we learn how to solve quadratic, so polynomial equation it is used. We use factoring method. Okay, so we're gonna use this, not this. Okay. Okay. So let's go through some example here. So I want to solve a third degree polynomial. 4x third plus 12x squared minus 9x minus 27 equals 0. This is a third degree polynomial because the highest degree is 3. Okay, and again we're going to use factoring. However, in factoring, most of the time we have to use G-shape. If you look at the fourth term here, there's no G-shape, there's no great common factor, so I have to factor it by grouping. Okay, I'm going to group the first two terms and the last two terms, and I can find G-shape. So see, 4x cubed and 12x squared, I find G-shape, it gives you 4x squared, right? Because in number 12 we have 4, in x cubed we have x squared, so we always to take this, the greatest common factor, which is the smallest that's same common. Okay. The smallest factor, the same common, I can say that. Okay. Okay, so you have x here and 3 here, and as this on this I have negative in common. I have in 27 we have 9, because 27 and 9 times 3, so I'll take 9 out. X plus 2 equals 0. Okay, now what I see that the first term and the second term that contain x plus 3, so I can find the great common factor again, which is x plus 3 in common. If I take x plus 3 out, I have 4x squared left minus 9 equals 0. I almost there. However, we have to keep factor into the end. Okay, until the time we cannot factor anymore. In this case, we still can. Okay, we still can factor more, because over here is in the form 4x squared, we can convert into 2x totally square, right? Minus 9 is 3 squared. Okay, so right over here I have the form a squared minus b squared to give you a minus b times a plus b. So a in this case is this. Okay, and b is 3. A is 2x. So if I apply this formula, this formula you already learned in intermediate algebra. So if you jump to Valencia straight from high school. I believe that you already learned this also, but it's kind of a long time ago. But that's why I just want to remind you of this by writing it over here. Okay, so they become what? Become a minus b, which is 2x minus 3 times a plus b equals 0. Now, what I have here, and I see that I cannot factor anymore. So the decision that you should factor more or stop factoring, that decision you have to make yourself. Okay, no way can make that decision for you. Okay, you must be able to see that if we can factor more or not, or we stop over here. Okay, so you must be able to see that by using formula, by all the knowledge you already learned in intermediate algebra or in high school. That decision no one can help you. Okay, because mathematics is very transformative. For this example, yes, you can see that easily, but if I might give you some another example, another problem, then you have to make your own decision that if you should keep factoring or you can stop there. Okay, and the only way that I can help you is I provide you with formula, but the ability of seeing the problem or of seeing if the equation can be factored more is about you. Okay, I know it's kind of hard because sometimes it's very hard for you to see if it can factor more. That's why we need to do a lot of problem. Okay, so right now I have these three factors multiply each other, and I'm going to use zero product property. Zero product property we already mentioned when we solve a quadratic equation in class. Okay, so this one I can split x plus 3 equals 0, or 2x minus 3 equals 0, or 2x plus 3 equals 0. Okay, and again, you remember for zero product property I always have to put all. So this will give you x minus 3, x equal to 3 over 2, and x equal to negative 3 over 2. Okay. Okay, and for polynomial equation you don't have to check, but most of the time it works. Okay, most of the time, unless you have an imaginary solution, then it doesn't count. We always want to solve for the real one. Unless I just say that go ahead and solve for any kind of solution, and you have to solve for imaginary equation also. Okay, so in this example it's just a third degree. Let's do another example that contain higher degree, for example like 5th degree or 4th degree. Okay, let me see. For example, I have this x to the 4 equal 27x. Alright, so we always want to have 0 on one side. Okay, that's like the rule. We always want to have it. So let's just go ahead, subtract both sides, then find factoring. I want to find the great common factor. I want to factor this polynomial, and the way we factor, we have to find great common factor. So if I take a factor, okay, and again right here is in the product form already. I can use zero product property, so I have x equal to 0, or x to the 3rd power equal to minus 27 equal to 0. Okay, so they give you what? X to the 3rd power give you equal to 27. Okay. Okay, and over here I take square root to give you 3. Alright, my question here is that if I solve for real solution, okay, if I solve for real solution, your answer is correct. However, if I just go ahead and put the question like solve for solution, then you miss two solutions. You just missed it. Why? How I know that? Because the highest degree of the polynomial show us the number of solutions we have. When we solve quadratic equation, quad means second degree. So every time you solve quadratic equation, we have two solutions. Sometimes we have one solution, but it's repeated, so it's still considered as two. When we solve for third degree, we have three solutions. This is the fourth degree. How come you have only two solutions? So you miss something. And where do you miss that? How do you know that I missed? It's a part right over here. A lot of students will commit this kind of the mistake right over here. Instead of keep factoring, so remember back when I did example 1 right here, I said we have to factor all the way out. So instead of keep factoring over here, you apply the zero property right away, which means that you're gonna miss the solution, because over here I can factor more. Because look at that, this is the same as this. Okay, this is the same as this, and this is the same as this, and this is in the form a cubed minus b cubed. So another formula, okay? You already learned this in intermediate. So a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So in this case, your a is actually your b 3. So I have to keep factoring. So a minus b, a squared, a is x, okay, b is 3a squared plus 3x plus b squared. So I have x equals 0, or x minus 3 equals 0, or a quadratic equals 0. So the solution you missed, that is come from here, from the quadratic, because you have to keep factoring more here. You did not factor completely, so the solution you missed is from this. And if I find a discriminant of this, I see that it's give you the discriminant is less than 0. It means no real solution. However, we still have imaginary solution. So if I apply the quadratic formula, it gives you another solution, which is this. Negative 3 plus minus 3i square root 3 over 2. So here we have totally 4 solutions: 0, 3, 1 plus and 1 minus. It's totally 4. Okay. Alright. So when I'm asking you to solve for a solution, you have to get everything. Okay. And how would I know that you have enough? By look at the highest degree. This is the 4th degree. It means you have 4 solutions. 3 degree means you have 3 solutions. If it is 4 degree and you have only 2 solutions, it means you miss something. So on the test, if I ask you for solution, it means that you have to get all kind of solution. There's a real solution. There's a real solution. The solution that contain I, we call the imaginary solution, or sometimes we call it unreal solution, okay, or complex solution. Okay. All right. So for solving polynomial equation, most of them will give you just something like that, probably higher degree. However, the problem with higher degree, you also apply the same way. You find great common factor, and you just keep factor until the end. Okay. Then you solve for the solution. Okay. Yeah. So I think that's all for the second lecture. if you guys have any question during the lecture video here, just let me know. Just put a comment on YouTube, or you can put a comment on Canvas. Okay. I'm going to give you another example later on in class, but hopefully we have enough time, because yeah, hopefully that by Monday next week the school already open. So right now, as far as I know, the hurricane has kind of go pretty slowly. So yeah, so I think that's good for the second lecture already. Most of the time I review something like that. I probably increase the time 4 degree to 6 degree, but you always have to bring everything to one side, set equals 0, and try to factor 5 greater common factor, and it'll give you something. And but remember, you always have to factor on the way out, otherwise you're gonna miss solution, as I already did here. Okay, this is just a demonstration. Okay, most of the time I'm not gonna miss any solution. No, just a demonstration of the mistake most of students have. Okay. All right. So I'll see you next time in class. Then we're gonna start section 1.7. All right. Thank you so much. All right. Bye bye.